ke ataupun Melayu je untuk speaking? Okay, saya start dengan English lah. Okay, so hello everyone. Today I'm going to talk about GraphQL. I will be introducing you with the basics of GraphQL. Okay, so before we begin, allow me to introduce myself first. My name is Ashraf. Currently, I'm working as a software engineer here at RunCloud. I've been with RunCloud for over 3 years since my internship. So RunCloud is my first company. Okay, so actually today is also my first time giving this kind of talk teaching. So please forgive me if there's any. Okay. So that's enough about me. Okay, so we know that recent years the chemical industry has booming for the past 20 to 30 years. So there's more technology introduced, there's new development style, and because of this, application development or mobile apps development has become very complex. Okay? So there's no more pulling some data from the database. That's the thing of the past. So this evening, when I was making the slide, I found this statistic. Okay, so this is so there's actually 8 billion population in the world, but there's 5 billion users. So this means shock lah. There's 5 billion users, right? So every technical company is fighting each other to get the attention of the users. But it's also a shock for me that there's around 3 billion users with monitoring itself, right? Okay. So because of this, the company is fighting each other. They have more and more complex, we have more and more better user experience. So the developers find this harder to develop. We have to get data for various resources. So the whole your API like REST has become obsolete. So that's why the second one, the second one is GraphQL. So to put simply, GraphQL is a modern approach to replace the computing. Okay, so we go to this one. Okay, so a brief history of GraphQL. Okay, so GraphQL is created by Facebook in 2012. At the time, they need a better data fetching approach so that they can use it across all of their products. We know Facebook has a lot of products like mobile apps, their website, and I'm sure there's a lot of services behind the Facebook. And they also have other stuff like Facebook ads and Instagram. So they need one tool to access all of those networks. So they create GraphQL. So after using it internally for a while, in 2015, they open source GraphQL. Okay, so why is GraphQL? GraphQL is a query language that has server-side runtime, typically served over HTTP. So let's get to know this word. GraphQL is a query language. So what I mean by this is GraphQL is a query language like SQL. For example, SQL language, like, let's say if you want all users from users server, right? So you just start a query, select all from users. Then the SQL will return all of the users' information from the database. So if you want a specific data, like only ID for each user, so you can do select ID of users. Then you have the SQL will return all of users' data. It will return all the ID of all of those users' data. So same thing with GraphQL, you can query like that, but the only thing different is SQL can only return you from SQL database. So GraphQL, you can return data from any kind of sources. You can either return it from one sources or you can do multiple sources. So any kinds, including microservices, REST APIs, or any database, MongoDB, PostgreSQL, anything. Um, Okay, so server side runtime. Okay, so server side runtime is GraphQL is running on the server side. The C is a backend language or server side language. So it's served over HTTP. So that's usage of HTTP protocols. So this on the right side is the image of an example of GraphQL query. So here we have operation point. We have two types of operation in GraphQL. The first one is query. Second one is mutation. So query is the equivalent of get for REST API. Mutation is the equivalent of post or delete on REST. So the operation is function. It's set a function. Variable definition is function parameter. Here is actually the GraphQL part. So name is attribute of the type. So this query here is telling GraphQL that we want hero data. We want name of the hero data from this episode. For example, if it was X1. So what can you retain all heroes name from X1? This query was. Okay. So this is a general overview of how GraphQL is. Okay. So this image shows you general process. Okay, so we are on the left side, we have devices. It can be mobile apps. It can be browser from a laptop. It can be a tablet. Then on the right side is the server side where the graphic accesses the request. Okay, so on the far right side, then we have something called GraphQL client. Okay, so we ran the query just now on the GraphQL client. So GraphQL client we then send to the GraphQL endpoint. So one feature here, GraphQL endpoint only has one endpoint. You can get any kind of data that the GraphQL possesses with a single endpoint. So with REST, you need a huge documentation like for each endpoint to access different kind of data. But for GraphQL, you only have one endpoint. Okay, so what happened here is you first draft the query from the front end side, and then you send to GraphQL backend to the GraphQL client. Okay, once the GraphQL reach the backend, we will implement the request. Is it a query or is it limitations? And then what type is requested by the client. Then we will pass to a resolver. Okay, this resolver is where we turn the request into actual data. So this is where GraphQL call all of the services. It can be from the database, it can be from another application, it can be from uh, REST API. So the resolvers will grab all of those data from everywhere and combine it into one schema that we already set, the types that we already see inside the pen, and we return to the file. This is also where the business process happens. If GraphQL also checks for if the user is allowed to access the data. So okay, so this is a bigger overview of the image design. So the front it can be view component, it can be React component. So view or React, they already have a package for GraphQL client. So you can do GraphQL query on view or React, and then you post on the GraphQL client. And you fetch from everything, whether it can be JS, Postgres, etc. Docker files, modeling the same facilities, APIs. Okay, so this is the example of GraphQL schema. This is actually a GraphQL with Laravel. Okay, so this is a Laravel GraphQL schema. So you in this main schema, you set where is the path for query, where is the path for mutation, where is the path. In this case here, I set the query inside app slash GraphQL slash query, set the mutation inside app slash GraphQL slash mutation, or the reports inside app slash GraphQL. So you can do any kind of search you want. There's no, it's okay. There's no limitation for this. So this is only a basic thing that you can add. There's more on the upside and downside, but we only talk about this one after. Okay, so this is the example of GraphQL. So GraphQL is a kind of button. Okay, so first we declare user port. So we then tell GraphQL the attributes the user has. So here I give the user three attributes: ID, name, and email. Let's say it is on the script, I call it single type. So here you can see at the lowest point, at the lowest part, there's owner. So at the owner here, I actually assign the part as a user part. Okay, so this is the ability of GraphQL. It can be nested. So for every server, there can be one owner. Or you can also make this multiple owner. You can also say this is a list of it. So it's like a normalization, one to one or one to many. To select that also exists in GraphQL. So this is the example of GraphQL query. Here you can see I set the on the left side. You can see user query. Say I set the type is list of things return a list of users. So the reason because I just use one singular variable. So I just reserve it as pretty much all users. So the next one is for server query. For server query, we have this arguments. So arguments is you can pass the agreements to GraphQL client. So you can resolve it based on this resolver lah. Okay, so for example, if I pass the owner ID, here I say if it sets agreements owner ID. So if there's owner ID, we only server that belongs to the user ID. So if front end doesn't send owner ID, then we return all servers. Okay, so here you can also call if the server is belongs to the services or the APIs, you can just call here and then combine it into a single list and return. We can also combine it to multiple lists, then return it. So GraphQL will resolve it, and then return to the file. Okay, so this is the example of the result. You can see we pass owner ID one. So we will only return server that belongs to all the owner ID. You can hear the owner of both server is non-TLC and so. Okay. So if you can see, we call there's actually two types here. The first one is server type and the second one is user type. So I mean it's all so I call server type and user type only in one form. So this improves performance. Okay, so this is the example of GraphQL implementation. It's mostly the same as query. There's arguments. So mostly implementation will have lots of arguments because we need to pass the data to get data. So the rules here is a validation rule. When you update that value, then uh, you can do the resolve here. Here is where you do the update operation. So the return type is boolean. So if the operation is success, we return true. If it's zero, then we return false. Okay, so this is the example of GraphQL result, implementation result. Here you see I set the GraphQL variable in the GraphQL. So whenever I change the variable here, it's like that. Send the request. So once the request is success, we will confirm. Okay, so key features of GraphQL. So first one is performance. GraphQL, it prevents overfetching and underfetching. Overfetching means you get more than what you want. For example, when you use REST API, if you say you only want user name of the user, right? So when you call the REST API for user endpoint, you will get all the data. You get the ID, you will get the email. So this actually use more bandwidth. So it's bad for low energy devices or people with poor internet connection. So we also prevent underfetching. It means that underfetching means that you get lesser than what you ask. For example, you want server, user, you want user info with every server that he possesses. Right? So the one you need to call 2 times for one user. If there's 2 users, then you have to call 3 times. First, you get the user list of user info. Yeah, if there's 2 users, then you have to call 2 times the server API for us. So it's slow down the significantly like if there's more on the list. So for GraphQL, you can fetch all of those once. Okay, sorry that this usually means that the API is more stable and fewer bugs in development because developer must follow the code that is already set. It also allows possibility of more intelligent tooling. Usually intelligent tooling look at the values if there's error or actually auto generation code. Hierarchy and declarative. This one makes the query easier to understand and easier to work with. Okay, by nesting the data, we can ask for related data, so we don't have to spend time combining the data again. So, if we fetch user data and then we fetch list of user data, then we fetch list of server data. So we have to combine, we have to assign each server to each user. Right? So it's tedious and fun. So with that, we don't have to. Before the because of the from server. So it means that from NDEFs, there doesn't need to wait for the NDEFs to finish implementing the API. So NDEF can just mock the API based on the GraphQL schema. So the first step you want to develop GraphQL, you always have to have a schema first. So once you have the schema, both front-end and back-end can do their job. So the front-end can just move the return data first while the back-end deliver the contract by loading the underlying services. So that's one is using the soft software. Okay, this one is because GraphQL only has one endpoint. So everything that the client wants to access it can be accessible by that one endpoint. Okay, so I think next one I will demo a bit about the GraphQL. So I will share my screen again. Uh, well, um, okay, so you can see the postman, right? So for example, this is okay. So this is the single source of truth for GraphQL. You see, it's only one endpoint, and we only use post. So refresh, with post, refresh user with post, refresh server with post, we update user also with post, with also the same endpoint. Okay. So for example, we want user, right? So we just do user like this, and we don't ID. Okay. So and we only request name for user, we can only all users with name. So if we add ID here, Then it will also return ID. So we only call once. We don't need to call multiple times. Even if you want two separate type, right? You want user and you want submit, these two types is not related to each other. So you can also call it uh, save. So you also get a summary for it. Okay, that's the beauty of GraphQL. So you can support. Okay, for support here. Okay, so this is the nested part. So next is the user information. So you can get support and then the owner that is related to support. In database, this is actually two separate table. Once. This is where I limit the user. So if I remove the documents, we return all servers with all the users. Okay, okay, so that's it. Oh, okay, so this one, this is a example of variables in the vector array. Here you can set variable here, you can then set here. So if you update the user, then the data will control. You can check here. Okay, yeah, see it is updated. Okay, okay. I think that's it for the basic of OKR. You have any question? Huh? So no question.
Oh, so I have a question, Ashraf.
Yeah.
Uh, for GraphQL, we only use a push, so all
Yes.
for the fetch for the update.
Yes. We only use post.
Like can GraphQL like delete that we want to delete?
Yeah. We also use post. Whenever you use this, forget we use query for post for update and delete. We use mutation. So we mutate the data. It's either update or delete. So if you want to delete, then we have to mutate the data. You have to create another schema, another resolver for delete. So this one is only a resolver for update.
For update. Oh, let's see. Think, that's the question. Thank you.
I think I can show the codes too. Mm, mm, Okay, so this is the cryptography. For it's not the implementation. So delete, you can just type in v1 here. You can call it the result for example. And then you have to create a result for the delete bisa.
Besar sikit Acap, tak nampak.
Besar. Besar tu. Okay, delete. Okay, aku disuat.
Besarkan font.
Oh, font. Okay. Now you see?
Jelas. Tadi tak jelas.
Okay, change. Okay, so this is the delete. Okay, so we have to register this delete to GraphQL schema. Okay, so this is the schema. We just add another one here. Delete this. Delete this. Okay, change. Okay, is there any problem? So we will delete this. Okay, so I deleted user one. So this the user one is gone. What is it? We use both use and for get we use full. Okay, any other question?
Understand. So which mean that for the update we use mutation, but for delete we insert the function inside the update. Correct, Ashraf?
What? Again?
Like for delete, like for to delete a data, we insert inside the mutation, right? Correct.
Mm-hmm.
Based
Yes.
on what I understand.
Mm-hmm.
Is it correct for?
Yes.
Oh, okay.
So any edit edit and delete all go to mutation. This one is get.
Oh, understand.
This one is we call it data structure. So no more question. So normally, I guess we can end it here today. Thank you everyone. I guess that's the end.
Hello?
Selamat. Okay, I'm finished. I'm open for questions if anyone has any. It's not, so I guess that's the end of. Yes.
Tak ada. Saya tak ada.
Tak ada.
Okay.
Thank you. Good night.
Good night.
Thank you, Ashraf.
Thank you, Ashraf.
Assalamualaikum.